I'm Archit, and in this presentation, I'll talk about detecting house numbers using convolutional neural networks. We see that all models give a very similar accuracy. However, these do not really reflect how they perform in the detection task, as shown later. FCNN is a technique which brings great speed in the task of segmentation. Instead of naive approach like sliding window and other image pyramid like approaches, this method can find and classify each pixel as a certain class, which gives us an overlay like map over our full size image, and this can be done in just a single pass through the model. This technique leverages the features that the CNN builds, and technically as CNN runs a sliding window anyways, we can reuse that to find the correct classes. This can be done by replacing the fully connected layers or the dense layers in Keras with convolution layers. During the evaluation phase, it returns a 3D shape for a single image where each pixel has a probability of each class in the third dimension. These are some of the results that the LeanNet 5 produces after getting converted to FCNN. Also mentioned in the report, we can just reshape the weights to convert to FCNN instead of retraining. These multicolored blobs are specifying which class are being detected, black being the background and the rest being 1 to 9 and orange being 0. If we ignore for a moment the difference in the digits and think this task as a digit no digit, we can see that the results are pretty good. They are able to detect the approx area without many false positive results. Here we can also see that this technique was able to detect the 7 which was not detected in the normal way. Clearly we see these results are bad. This is probably because the model thinks that there are numbers in the bushes. This technique is looking for any shape, size, affinitation, color, orientation. Ideally, this would be perfect, but this did not work so well for this dataset. As shown earlier, this dataset has a lot of noise, and I assume it's hard for the model to learn the correct features. Hence, when the model sees a certain feature that resembles the training image, it marks it as a digit. The original training data is also very small in resolution, only 34 by 18 pixels, and it also blurred. Hence, in my opinion, that's why the model is marking blurred areas as digits and other crisp areas as not digits. Here we see the comparison between three models, and clearly VGG does not do a great job. This does not necessarily mean that VGG is a bad architecture. It could also just mean that it was not trained or optimized properly. Left images show the results we get after running MSCR, and on the right we see how our model clears up all the boxes and leaves only the digits. The combination of MSCR and CNN is great but not perfect. One of the most common mistakes of the classifier was to predict 0 inside 8s and to find digits between the groups. First we saw the rotated version being classified correctly. Now we see zoom in and zoom out to show size invariance, and now we see the location invariance as it reaches on the top. Thank you.